Morning folks. My name is McNamara. I'm BIM manager with Coffey Group, based out of Athenry, and a lecturer part-time on GMIT's award-winning higher diploma in engineering and BIM. So just before we begin, a small bit about Coffey Group. The company was set up by two brothers in 1974 primarily as civil contractors, and has grown to 4 offices throughout Ireland and the UK, working in sectors such as rail, bridge, road, water, wastewater, infrastructure, flood defence and general infrastructure. So I'm dealing mostly at the moment with Coffey Water. These are some of the projects we've completed recently. Again, some of the clients we're working with at the moment. So Irish Water is our main client. We have a couple of the ITs and colleges in Ireland, along with a number of water schemes in the UK. So over the next 15-20 minutes I'm going to run through a couple of different things. We're beginning with our BIM journey, the drivers behind it, why we're doing it, what we want to see out of it. I'm going to go through a pilot project, which you see on the left, part of it anyway. We're going to look at how we use automation and fabrication to ensure that our design and processes and the building of our sites are as seamless and as lean as possible. Then we look briefly at some virtual and augmented reality that we're using in the office. So this pilot project, the drivers behind why we're implementing BIM in the office, Coffey's kind of had the vision to see that a while ago that it's what clients are looking for, and what all clients aren't asking for at the minute, they're in the process of readying themselves to look for it. So we saw that as a way to generate new business and meet client requirements, streamline our design activities while also improving the design quality, further integrating the health and safety into the design process. So again, this is further cemented by PAS 1192 Part 6. It was released a couple of weeks ago, and it's a framework to integrate health and safety information into the BIM process. It's improved information between ourselves, contractors and clients, cost monitoring and savings. Again, just some of the more practical applications that we're using first: time savings, visualizing construction sequencing, clash detection and avoidance, prefabrication, which we're going to look at later on, as well as aiding the facilities management and operation and maintenance asset handover, the automation of schedules and cut lists, and again just innovation just to stay ahead of the curve. So this is the pilot project we chose not long before Christmas. Again, you're looking at it thinking it's a shipping container. This is a containerised water treatment plant. Irish Water have ordered a large number of them. It's portable, so it can be loaded onto the back of a lorry. It's a 40-foot shipping container, and this can be brought to site if there is any problems with any treatment plants around the country. So the idea is to have a couple in each county that can be moved at almost a moment's notice and take over operations temporarily of that treatment plant. So there's 3 different types: A, B and C. What you see there is A. Again, the types vary as to the requirements of the site and the quantities of water to be processed. In a BIM sense, it's kind of unique, this project. There's no subcontractors involved. We're designing, we're building, and then we're handing over to the client, which doesn't usually happen on a construction job. So we chose this project for these reasons, to help get our internal processes set up first before we start collaborating with other clients on a larger scale. We have since delivered 2 larger jobs in probably a near level 2 BIM environment for Irish Water, with 4 more designs going out within the next month. There's no BIM requirement for this job, but Irish Water they're in the same position as us. They're beginning to get their company standards and strategy for building information modelling set up. So while we're using this as a pilot project, so are they. So they're using this to test the asset handover and transfer of data from our models to their own systems. So it's a brief construction sequence as to how the container is going to go together. This is used early on in the design process just to as part of showing Irish Water what we're actually planning to give them. So we had a number of success criteria for this project. Firstly, we wanted to deliver the project in accordance with relevant standards, and we decided early on to produce all the construction documentation through Autodesk Revit. We wanted to develop 4D and 5D models. So 4D will combine time, that we saw just a minute ago, the construction sequencing, and 5D to link our models with our costing platform, which we've already done. One of Irish Water's biggest concern was that all they had seen from projects using building information modelling so far was pretty pictures, essentially, and videos. So we wanted to give them some tangible evidence to show that it can be useful. So we've automated the transfer of asset information from our model through to their asset register that they can bring into their asset management software, IBM Maximo. So we're going to look at that in a bit more detail later on. We also wanted to develop our BIM library. This is vital, and it's something that's going to grow as projects are completed. This will grow, and it's a constantly moving or growing library. We wanted to automate as much as possible. It saves time, it ensures consistency, and it just removes human error from the equation. And we wanted to optimize pipe cutting for minimum waste. Again, we want to look at that in a bit more detail. So linking our models to Irish Water's IBM Maximo asset management system. So Irish Water is essentially an asset management company. So to have the right information as to what's on site, where it is very important. So every piece of kit on site needs to have 17 different pieces of information attached to it for their system. And on a site where you could have 1,000 pieces of kit, that's a lot of information for somebody to type in. So I'm going to show you a video in a minute as to kind of how we implemented this. We're the first company to achieve this with Irish Water. It removes any human error, increases the accuracy while saving time without loss of quality. So automation. We've been trying to automate as much as possible in the office. When you think of automation with BIM and mainly with Revit, the BIM authoring tool we're using, most people think of Dynamo. So we use Dynamo a lot recently. We don't use it as much as we used to, which I'll go through now in a minute. But Dynamo is it's a free open source graphical programming tool. It's installed with Autodesk Revit since 2017, so some of you might have seen it on your machines. And it allows the user to access the Revit APIs, the applications programming interface, essentially the code behind Revit, and lets you manipulate what Revit is doing and lets you do things that it was never designed to do. It was heavily influenced by the graphical programming tool Grasshopper for Rhino. It was used extensively on the Viva Stadium. And it's extremely useful for bulk manipulation and automating monotonous tasks. So just to briefly show you how it works. Dynamo is made up of nodes and wires. This is a node in the top right hand corner of the screen. So rather than typing in lines of textual code, you link up different nodes using wires that we're going to see in a second. So the node is made up of three parts: the title or the name, ports. Information goes in one side, generally to the left, and out to the other. And the main body of the node. So just to show you a quick example. That node is called point by coordinates. It's going to create a point at a certain coordinate, so it'll have a certain x, y, and z value. We can join these nodes up using wires, and we can see our result on the right. At the moment, there's nothing attached to it, so it's the x, y, and z are all 0. When I link the number 10 into x, it updates. We also have 7 and 4 on the left, and a code block with x plus y, which is going to add them together. So when we link that to the z port, we get 11. Again, we have a number slider that we can change the Y value. So this is just creating a point at the moment. That could be the location of certain elements inside a model that are being updated, and as you change them in your script, it will update automatically in the model. So in the past I've used this a lot on projects. We're beginning to not use it as much for a couple of reasons. In a larger office now with multiple people working on it, it tends to scare some users who don't have experience in it. So if you open up a script you want to edit and you're met with this, generally they just hit the red X, and we'll do that tomorrow. It's difficult to deploy and manage. If you've 6 modelers there that each of them need to use some of these scripts, it's difficult to give them the same script and make sure that they have the right pieces of software installed on the machine to run them all. And again, it can vary from version to version. If somebody updates the version of Dynamo they're using, it can cause problems as well. So Autodesk brought out Dynamo Player about a year ago. This alleviates some of the problems, but it's still not ideal. We still have the deployment and the issues with the different results from version to version. So the solution we found was, we kind of stepped a small bit away from Dynamo and we began producing some of our own add-ons for Revit. So we now have our 2 Coffey group toolbars built into Revit. We use them for transferring asset data, creating views, scheduling cut lists, placing views in sheets, and tagging elements automatically. It's just a quick video showing how we take the asset data from our model and bring it across into Wastewater's asset register. So you're going to see 4 pieces of equipment inside this container. There's 2 pumps and 2 UV reactors. So our pumps on the left and the reactors on the right. We're going to go up to our Coffey group toolbar and select our asset register add-on. We can choose Wastewater's template for their asset register, and we can hit OK. Again, this is in real time now. This is exactly what you see when you run it, and it starts to populate all the information for the models across into the register. The beauty about this is, first of all, somebody doesn't have to type them in manually. So it's everything from serial codes, locations on site, install dates, warranty periods, preventative maintenance strategies. So is it maintained monthly, weekly? Who maintains them? Is it a specialist? Is it the caretaker on site? So if you have a couple of hundred pieces of equipment on site, this saves a huge amount of time and it removes error. Moving on to fabrication, this ties back into our automation as well. So these containers are being made on site or at our head office in Athenry. So we've kind of gone away from the traditional 2D drawings and we're issuing our fitters something like this. So we have a 3D model on the left. Every pipe is tagged, it has a unique number. Again, we have a section at the bottom, these numbers all that tie in together. And we have a cut list on the top right. So we created all of our content. Pretty much everything you see there, bar some of the valves, were created in-house. It means work is front-loaded, takes a bit longer at the beginning, but we're going to use these throughout the course of the next few years. So we just see in a bit more detail the cut list on the right, along with our model on the left. So rather than the fitter is actually having to take measurements of 2D drawings and work out how long to cut the length of pipes, because of course it's going to be passing into the fittings before it's glued in place. We developed this. This is another add-on we use, and it automatically exports, and there's an algorithm to break down the pipes by pipe length. So we're using 5 meter lengths of pipes. They're coming straight from the supplier, and traditionally the fitters would just start, I suppose, cutting wherever they begin. They start cutting pipes and you're left with loads of ends of pipes at the end. So our script and algorithm calculates the best way to fit the amount of pipes we need to cut into those 5 metre lengths of pipes. So you can see there on the left in that assembly there's I think it's 14.7 linear meters of pipe. Again, we used 15 linear meters to cut those by using these cut sheets. This also saves a huge amount of time. The piece you saw a minute ago, the fitters have been allowed just a day and a quarter to cut them and fabricate them, and they were done by lunchtime in the first day. So there's huge time savings involved. They're just some of the parts before they're actually put together on the top right. I'm not sure if you can see, but the second image is a number of the cut pipes that are numbered. So once they're cut and numbered, essentially we want IKEA after that. We want to be able to put piece 1 into piece 2, into piece 3 and so on. Alleviates the risk of any errors. And on the bottom right we see the actual waste from those three 5 metre pipes, which is a lot less than what we usually would have had. So we've been looking an awful lot just at ways of, I suppose, being innovative and helping our clients understand what they're getting. It means we can make design decisions earlier in the design of the project. So we've been looking at virtual reality and augmented reality. So I'm not sure if you're aware of the difference between virtual reality and augmented reality. So the gentleman in the top right hand corner is wearing virtual reality goggles. Everything he sees in those goggles is computer generated. So he doesn't see any of the actual world around him or his surroundings. It's purely generated by the computer. Compared to that then we have augmented reality. So some of you might have seen the Google glasses a couple of years ago, Microsoft HoloLens, daiquiri goggles. These are all augmented reality. So if you were to put these on, you'd see your surroundings. I'd see ye, but I'd see graphics or information superimposed over that image. It's a bit similar to something you'd see like an Iron Man. He's wearing his helmet and he scans a face, tells him who it is. It's similar to that. So again, this is an example. They're daiquiri goggles he's wearing. He's looking at the wall and he can see what's inside the wall and where it is. Again, this is only as accurate as it's modelled. If something is modelled incorrectly, it kind of throws the whole process out the window, really. So I'm going to show you a quick video that we use in our design process. It's an augmented reality video using an iPhone walking around the container, and just a screen capture from the phone. The container at the moment has been essentially dry lined, and we have PVC sheeting along the inside and along the roof, and there's a checker plate floor being put in. So other than that, everything you see is generated from a model. No sound, is it? Okay. So this is all computer generated, everything you see here, and this is just me walking around with my phone. There's no processing afterwards. And almost our whole design chain uses this. The designers use it so they can walk around and actually see what they're designing. Health and safety use it to check health and safety requirements, and they can go back and tell us we need to change this, we need to move something much earlier than they would have done previously in the design process. Where it's going to play as well, our fitters and our operation and maintenance guys, they can come in and look somewhere and say, well, I need to come in here and change a pump at some stage, I can't get through here. So while it might meet the requirements for a passage or access, practically it doesn't work for them, and this allows them to see that much better. This was an area that was of particular concern for Irish Water. It's a valve room. There's a number of valves inside, and they were concerned as to whether you could get in and access those and maintain them. So again, they were down at our office, and we went out and had a look around the container and showed them this, and it just proved that there was enough room for them to be able to maintain these actuators. So something like this a year ago wasn't really possible for a small, not a small company like us, but most of the videos I'd seen were in academic or research areas. They weren't being used in the real world, I suppose. So this is coming more and more on board every year, and it's progressing rapidly. Augmented reality is due to surpass virtual reality for funding and for essentially money taken in from the technology this year, by the end of 2018. So it's something that is coming online soon, and you will see it an awful lot more. So, any questions?
What program did you use for that augmented reality?
It's a company called Visualive. They're in the States. I kind of pestered them into giving me a beta version while they're developing. So it took a while to get it from them, but it's pretty good now. It's expensive. I don't know if we're actually going to buy it, but it is pretty costly.
Just thinking of other implications of it, like say as architects, you're designing a building for somebody, model and Revit, stick it in on that.
Yeah.
Bring them to the site, video it, which is a brilliant idea.
You could have them on their greenfield site and walk around their building essentially.
Yeah. Or even for planners that might have an issue with building.
Yeah.
It'd be a great idea for.
Yeah, no,
Great tool.
it's much easier than seeing you can show them photorealistic animations and stuff, but it feels a lot more like you're there and you're inside the actual building. So.
And those containers, that was a transportable facility for local authorities and water authorities,
Yeah.
where they might have to boil water notice or something.
Yeah.
Is it?
And
So
they
they're
can
temporary, yeah.
they are temporary, yeah, and they're to be moved around essentially. So a number of sites will have essentially a slab cast into it that these
Right.
can be put down on, and after that then
Basically rent them, lease them, is it, or what happens?
I'm not sure how Irish Water plan on the business that side of it,
Yeah.
but they'll be able to dispatch them within a couple of hours.
Yeah.
So.
And your Coffey Revit add-ins,
Yeah.
do you create them in-house?
Yeah. So we still use Dynamo for some of them, but again, it's some of them. We have a software engineer in house, as well as 5 people in our IT team. So I'd have a small bit of experience with them, but again, it's not handier to get advice from them when you're stuck. So yeah, we create them all in house.
Is that automated Excel sheet, is that Coffey compliant or is it just bespoke to the client?
It's bespoke to the client. I know they're talking about looking at Coffey at some stage. Again, I suppose what they have at the moment is something they've always used, and it's very targeted towards water and wastewater. We'll go into a lot more detail than Coffey would for different types of valves or actuators or pumps. Apart from that, then there's a huge amount of guidance on it. They have an inch-thick document as to how to use that asset register. So again, there's no shortage of guidance on it. So I'm not fully sure where they're going to go with that.
Who wrote the algorithm that you mentioned to reduce the extent of wastage?
So we grew up with that in the office. It's used for everything from, if you have a shipping container, how are they going to stack that most with boxes without leaving the minimum amount of air? Almost like Tetris, how are you trying to fill up every gap? Or it's used for, it's called the box packing algorithm. If you have a sheet of material and you want to cut squares out of it, how are you going to best do that? So again,
How to get the maximum number of pipes that you need out of a length of 5 metre pipe.
yeah.
But you can see that being applied on so many other situations.
It's used I know it's used a lot in the States for cutting of steel and metal and the likes of that.
Yeah.
How they're going to cut it and best get the quantities they want from the minimum amount of raw material.
Very interesting.
Sorry, Andy, did you say you got 5 IT guys and
Yeah.
software, and they work full time on kind of developing scripts?
No, just they're part of Coffey. They're just developing and keeping everything going. So we use SharePoint a lot, so they're pretty busy. They're just keeping all their IT systems running, especially the ones where water treatment plants don't tend to be in built-up areas. They're generally out of the way. So we've had ones in Scotland where you didn't have phone signal for 30 kilometres. So they have to try and figure out how you get an internet connection to site, with a sat link or something like that. So they're kept going like that. They're pretty busy.
And would Coffey have a sort of a 10-year responsibility then to run this? You know, like you design, build, operate. Is that how it works a lot?
As far as I know, there isn't an operator on these.
No.
No, because essentially a lot of them could be sitting there for a while until they're needed.
Because Glen Echo were talking about the water scheme.
On our other plants then, a lot of them are the larger, I suppose traditional water treatment plants, they're design, build, operate, majority of them.
They're permanent structures, whereas these are mobile.
Yeah, these are transportable and mobile.
Yeah.
So again, it's in our interest to use
It's an
the asset.
interesting when you've got that type of,
We chose that because it's complicated and it'd be to get our internal system set up first before we go expanding and collaborating.
So what are you presenting at Autodesk University?
I think of the title now. The gherkin in the cloud, it's linking up Autodesk Fusion 360 to Dynamo with Revit. So it's an hour and a half hands-on lab where they're going to produce essentially the gherkin. So 30 St Mary's Square.
Yeah.
St Mary's Act, sorry.
Very good.
But we're going to produce that within the hour and a half.
Who's we?
Well, I'll be presenting it and the participants at Autodesk University.
Very good. Well done.
So.
Okay. That's really good. Thank you.
Okay, thanks.
Any questions?